Dear aspirant, in this module, we are going to see the randomization aspects of the clinical trials, what is the importance of randomization and its application. What are the benefits of randomization? The basic benefits of randomization are the randomization eliminates the selection bias. The randomization balances the groups with respect to many known and unknown confounding or prognostic variables and forms the basis of statistical tests. Also, randomization is the basis for an assumption of free statistical test of equality of treatment. In general, a randomized experiment is an essential tool for testing the efficacy of the treatment. What are randomization schedules? Randomization requires generating randomization schedules which should be reproducible. Generation of a randomization schedule usually includes obtaining the random numbers and assigning random numbers to each subject or treatment conditions. These random numbers can be generated by computers or can come from random number tables found in most of the statistical textbooks. With respect to randomization schedules, for simple experiments with a small number of subjects, randomization can be performed easily by assigning the random numbers from random number tables to the treatment conditions. However, in case of large sample size situation, or if restricted randomization or stratified randomization to be performed for an experiment, or if an unbalanced allocation ratio will be used, it's better to use a computer programming to do the randomization schedule, like SAS or RSOM. Proper randomization ensures no a priori knowledge of group assignment. Hence, researchers, subject or participants and others should not know to which group the subject will be assigned. Knowledge of group assignment creates a layer of potential selection bias that may taint the data. Inadequate or unclear randomization tended to overestimate treatment effects up to 40% compared with those that used proper randomization. The outcome of the research can be negatively influenced by the inadequate randomization. This particular slide talks about the randomization schedule for a two-way crossover bias study. So here are the study participants and they are randomly assigned to sequence 1 or sequence 2. What is sequence 1? Sequence in 1 is first they will take treatment A followed by treatment B in the period. Sequence 2 is first they will take treatment B followed by the treatment A. So this will be, for example, in case of 12 subjects, 6 subjects will be assigned to sequence 1 and another 6 subjects will be assigned to sequence 2 in a random manner. So this is how a randomization is performed in a two-way crossover bioequivalence study. What are the types of randomization? Many procedures have been proposed for the random assignment of participants to treatment groups in clinical trials. Common randomization techniques are simple randomization, black randomization, stratified randomization, and covariate adaptive randomization. Now we will see what is simple randomization. Randomization based on a single sequence of random assignments is known as simple randomization. The most common and basic method of simple randomization is flipping a coin. For example, with two treatment groups, control versus treatment, the side of the coin, head is control, tail is treatment, determines the assignment of each subject. Other methods include using a shuffled deck of cards, that is even is control, odd is treatment, or throwing a dice below and equal to 3 is control, over 3 is treatment. So the random number table found in the statistics books or computer generated random numbers can also be used for simple randomization of a subject. In simple randomization, the randomization approach is simple and easy to implement in a clinical research. In large clinical research, simple randomization can be trusted to generate similar numbers of subjects among groups. However, randomization results could be problematic in relatively small sample size clinical research, resulting in an unequal number of participants among groups. This particular slide presents a simple randomization. The simple randomization to divide 12 subjects into 3 treatments. Here, the 12 subjects are divided into 3 treatments equally and each subject assigned randomly to each group. For example, subject 1 assigned to treatment 3, subject 2 to treatment 2, subject 3 to treatment 3, subject 4 to treatment 1. And you can see each treatment group will be equally allocated and randomly allocated. Now we are going to see about block randomization. The block randomization method is designed to randomize subjects into groups that result in equal sample size. This method is used to ensure a balance in sample size across groups over time. Blocks are small and balanced with predetermined group assignments, which keeps the numbers of subjects in each group similar at all times. The block size is determined by the researcher and should be a multiple of number of groups. With two treatment groups, block size will be either 4, 6 or 8, for example. The blocks are best used in smaller increments as researchers can more easily control balance. After block size has been determined, all possible balanced combinations of assignment within the block must be calculated. Blocks are then randomly chosen to determine the patient's assignment into the groups. This particular slide talks about a typical block randomization in a 12 subjects with two treatments. The block size is 2 into 2, 4, and 12 by 4, there will be 3 blocks. So to make it more understandable, what here is that there is a first four subjects will have the block 1, which compulsorily have 2 B treatments and 2 A treatments. And the next 4 subjects again in block 2 will have at least 2 A treatments and 2 B treatments. Similarly, last 4 subjects also in block 3 will have 2 B treatments and 2 A treatments. So each block will have 2 B treatments and 2 A treatments, but these 2 treatments and 2 B treatments will be randomly assigned within the block. You can see in the first block BA and second block A and third block BBAA, like that. So there are 3 blocks where that will be equally assigned for each within the each block, and the treatments are equally assigned. So this is how the block randomization will be carried out. Now we are going to see about stratified randomization. The stratified randomization method addresses the need to control and balance the influence of covariates. This method can be used to achieve balance among groups in terms of subjects' baseline characteristics. Although stratified randomization is a relatively simple and useful technique, especially for smaller clinical trials, it becomes complicated to implement if many covariates must be controlled. Stratified randomization has another limitation. It works only when all subjects have been identified before group assignment. However, this method is rarely applicable because clinical research subjects are often enrolled one at a time on a continuous basis. In this particular slide, we are going to see a classical example of stratified randomization. In a stratified randomization, suppose there are two prognostic variables, that is age and gender. There are 4 strata can be constructed in this example. There are male with the age less than 18, male equal or more than 18, female less than 18, and female more than 18. So here the treatment A will be assigned to 12 subjects equally for the treatment B also. And in case of age more than 18, you have 36 and 37 in group A and B respectively. In case of female, again it is 13 and 12. And in case of female more than 18, it will be 40 and 40. The strata size usually vary. Maybe there are relatively fewer young males or young females with the disease of interest. The objective of the stratified randomization is to ensure balance of the treatment groups with respect to the various combinations of the prognostic variables. Simple randomization will not ensure that these groups are balanced within these strata, so permuted blocks are used to within each stratum are used to achieve the balance. You can generate the randomization online using the software with the website called www.randomization.com. Important to note that the seed of the randomization number generator is obtained from the clock of the local computer and is printed at the bottom of the randomization plan. With this, we are concluding the module in regard to the randomization and its application in the clinical trials. Thank you.